Okay. Um, Hopefully it's live. Everything is working. Yeah, welcome back. So today it's day 12 of Advent of Code. We're halfway through December already. Or halfway to Christmas anyways. I haven't bought a single Christmas gift. That's getting kind of critical. Um, but yeah, anyways, we're back with day 12 of our Advent calendar. I realize now what the skipping was, like skipping over parts. Apparently now we're going like a bit back up for day 13. So it seems like we're coming here to maybe an island, and then maybe we go like up here instead. Oh, it does look like we're actually coming to the island. Um, oh, and this, I was wondering what this thing was, but of course it's the curvature of the Earth, because the Earth is round. And this is the North Pole. I see, I see. Okay, cool. So yeah, same as usual. We haven't done anything yet. I haven't looked at the task. I literally just logged on my computer, so I don't even have the benefit of having seen someone else's solution, or I don't see their solutions, but I see them talking about them. Uh, so today I'm completely out of nowhere. Um, and I looked at my Advent of Code 2018, which was the last one I did. I think I stopped around day 11. So this might get interesting from here on. Day 12, rain risk. Your ferry made decent progress toward the island, but the storm came in faster than anyone expected. The ferry needs to take evasive actions. So that's why we're going back up. Unfortunately, the ship's navigation computer seems to be malfunctioning. Rather than giving a route directly to safety, it produced extremely circuitous instructions. So going in circles. When the captain uses the PA system to ask if anyone can help, you quickly volunteer. The navigation instructions, your puzzle input, consists of a sequence of single character actions paired with integer input values. After staring at them for a few minutes, you work out what they probably mean. I mean, a few minutes? Sand is thick. Like in dummy thick, not in thick. Move north by the given value, move south by the given value, move east, west. Okay, I guess these ones. Turn left by a given number of degrees, turn right by a given number of degrees, and F means move forward in the direction that the ship is currently facing. The ship starts facing east for you guys. Wait, is Twitch not working? No, okay, it's working. It was just spinning on my screen here. So yeah, we start by facing east. Only the left and right action change the direction the ship is facing. So yeah, that is if the ship is facing east and the next instruction is north 10, the ship would move north 10 units, but would still move east if the following action were forward. So we have apparently some super powerful side thrusters on this ship. So we move forward by 10, north by 3, forward by 7, right 90 degrees, forward 11, etc. These instructions would be handled as followed. Yeah. So move the ship 10 units east, because we start by facing east. So 3 units to the north. F7 would move another 7 units east, because we haven't changed direction. Right by 90 degrees, so now we're facing downwards. And F11, so we go 11 down. Right? At the end of these instructions, the ship's Manhattan distance, sum of the absolute values of its east-west position and its north-south position from its starting position is 17 plus 8. So these numbers is 25. Figure out where the navigation instructions lead. What is the Manhattan distance between that location and the ship's starting position? I haven't looked at this. I'm guessing Manhattan distance is because Manhattan is pretty much just like a straight crisscross of roads, and in that sense, this would be the shortest path if you have a grid with unit size 1. Typically, like this would of course be like the distance to go there and there, not this distance, which is shorter for a ship. But in Manhattan, the streets are crisscross, so going like that, and for pixels on a monitor, going like that and going like that is just as far. Anyways, yeah, so we need our puzzle input here, and I want to check something. Interesting. So it seems like our day 12 input.txt. It seems like our left and right and like our angles are always right angles. Let me just quickly check that. Yeah, so as you can see, all of these are right angles. Same for this, yeah. So we have no like turn 33 degrees, stuff like that, which makes our job a little bit easier. Okay, so let's think about this. So east-south, I'm gonna say is like x and y, and then north is minus x and west is north is minus y and x is minus east. So we are going to start us out at, well, let's start by, we're only reading the instructions once so far, so we don't actually need to parse them into any structure. So let's start by saying x is 0, y is 0, and our heading is east. And let's create a type here. With direction, so north, east, west, south. There. I mean, this could be one line. I doubt we need another type. Okay, so for a line in lines of our input file, so we are gonna case on the first character. So normal switch case statement in nim, but we apply it to a character of a string. So now we're just checking like the first character. And we have the cases of course, north. We have of south. We have of east. We have west. We also have, what is it, left, right, and forward? Yeah. Left. We have right. And we have forward. Okay. So when we get n, we know that our y is going to have to move upwards. So y minus equals, parse the integer, just skip the first character because the first character is this sort of command. Same for south, but now we're going in the opposite direction, so we're going down. East, we're doing x, x plus because we're going this way. And for west, we're gonna do minus. So left, now we need to determine if we're going, so it had, we have 90, we have 180, and we do have 270, but we don't have any 360. Okay. So we can actually just do a case for line like so. We don't actually need to parse this as an integer. And we can say 90 degrees. We just say that our heading. So actually what we can do here is north, east. If we switch south here, west, you know what we can do? Let's do this. So let's assign these to their sort of angular, and we start with east. So let's make east 0. I'm going to move north all the way to the end. East, and then south. So by adding 90 to our initial position, we will be heading south. Adding 180 to that, we get west, and 270 we get north. Okay, that means we can simply do, instead of doing this, we can actually say our heading is heading.int plus the value that we get. So we are actually going to parse it. And all of that modulo 360. And all of that as a direction. Actually, just let's write direction here. Makes it a bit clearer what we're doing. So yeah, what we're doing here is that we're taking our heading, which is this stuff, and we're converting it to its integer value. Then we're adding the number of degrees, and we're adding because we're going, oh wait, we should actually be subtracting if we're going left. So we're subtracting because we're going, if we're heading east and we want to head north, then we have to turn left by 90 degrees. So that means our heading is now 0 minus 90. Not 100% sure if not 100% sure if let's actually just test minus, what did I say, minus 90 modulo 360. Yeah. So we need a modulo operator that handles negative numbers. Oops, maybe math was a bit too generic of a term. Do we have a modulo operator for mod that was for floating numbers? Floor mod. What does this do? Right. Yeah, so this seems like what we want. So we are going to import the math module. And instead of doing mod here, we're going to do floor mod. Floor mod sounds like a super dull version of Gary's mod. Not that I've played Gary's mod, so it might be super dull to begin with. Name secret. Let's do minus 90. Oh, let's import math. Minus 90. Floor mod 360. this should hopefully give us 270. No. Wait, maybe that. Just making sure that it didn't apply the... Yeah, okay. So it's parsed this as 90.floormod and turned that negative, the result of that. Yeah, so that works fine. No, it's quit. So we can do the same for right, but now we want to plus. So basically what we're saying, so going east, then turn right. Yeah, we're going east, turn right by 90 degrees. We want to turn it this way. So we add 90 to our sum, and east is 0, south is 90. So now we're turning downwards. I mean, we didn't need to create an enum out of this, but whatever. Now we know we have nice bounded values at least. Left, right, and going forward. Actually, here it comes in handy because we can do a case of heading and say off east. We want to say x plus equals. Actually, we just want to do these. As you can see now, I'm sort of repeating myself. So I have a good idea for a little reformat here afterwards, if this works. X minus south is plus, and north is minus. There we go. Now we can echo out X, and we can echo out Y. Oops. Oh, it didn't like having this on a single line. Huh. Oh, wait. Of course. I thought that looked weird, but I couldn't quite put my finger on it. Yeah, we're missing cases. That's technically an error. We also, of course, need the string utils package to do the parse int stuff. There we go. And let us also just quickly grab the example here. Oh, this is actually a really small one. North and south. Why not X? Oh, right, yeah. I made a mental note to myself of fixing that, but I forgot apparently. Let's do for line in this dot split lines. If I ever see anyone writing actual code like this, I'm gonna come to your house, and not in a fun way. Part 1. 17 and 8, which are the numbers that we expected. Now I'm a bit curious. I mean, I guess we should do this, right? Like abs is the absolute value. So if we're going, like if we're too far north, then like if this was a north value, it should still be. I think it's by value and not like absolute, because absolute wouldn't really make sense. There we go. Yeah, as you can see, this one is negative. That should be our answer. Yay! Okay, so the reformatting I was thinking of, since we're doing basically the same here and the same here, and as Narimuran just pointed out, that can lead to errors, and that will lead to errors. In fact, it just did lead to an error. What I think I would do instead is I would say something like this, and then move this part down here and change this for current heading. And then I would say here I would just overwrite the heading. Current heading equals north. Current heading equals south. Current heading equals east. Current heading equals west. These of course need to change the heading. This so this F now doesn't have to do anything. This is technically an error, like we get something that we don't expect. So I kind of don't want to bunch them together. But yeah, then we do this just based on our current heading. So if we're coming in here and we only hit F, we haven't changed the current heading from our actual heading. So when we go up into here, it's going to still give us the same result. Ooh, and it didn't. Oh, because we're not moving for left and right. So if line 0 not in left or right, only then should we move. There we go. That's the result that we expected. There is, you can attach strings as well to enums. I mean, now I'm just doing this because I want to show off some nym features and show how nice and clean looking we can get our code. So we can say if line 0 in this set of characters, so n as E and west, or W, then our current heading should be parse enum of direction, this line 0. That should theoretically save us these. Parse enum cannot be called. What? Okay, that required a string. Oh, and this would be the other way around. So there's sort of like a value stringification thing. So by default, enums have value based on their, so the first one is just assigned 0, 1, 2, 3. So what we were doing earlier, we were just assigning a value to them, but their string representation would still just be their name. Now I've set their string representation to be this string and their value to be this thing. So now parsing the enum, like this would parse as west. And we can say just else, do that. I mean, it would never, like, they don't interfere, but just to sort of make the logic a bit clearer. So this should still give us the same thing. Yep. So now we don't have to repeat all of that, like n means north, s means south. we just parse this letter as an enum. I mean, we could also do something like a try here. We could do something like this. So this will throw an exception when they're not one of these values. And then we could check like our other stuff. That would also work fine. It's just a matter of preference, I guess. I mean, here we have to repeat these again, and we have already defined them up here. So maybe this is the cleaner way of doing it. Yeah, there's not really much more we can do to clean up. I mean, we could change this. Like we could put this logic here in a template or something. Here we can say we can just do this. I mean, now all of this is just nitpicky stuff to make it look nice. Anyways, let's get on with part 2. Continue to part 2. Part 2. Before you can give the destination to the captain, you realize that the actual action meanings were printed on the back of the instructions the whole time. Oh, right. So now we get new rules, I guess. But okay. Right. Almost all of the actions indicate how to move a waypoint, which is relative to the ship's position. Action N means to move the waypoint north. Action S means to move the waypoint south. Same for east and west. Action L means to rotate the waypoint around the ship left, counterclockwise the given amount of given number of degrees. R means to rotate the waypoint around the ship right, clockwise, the given amount of given number of degrees. Action F means to move forward to the waypoint a number of times equal to the given value. The waypoint starts 10 units east and 1 unit north relative to the ship. The waypoint is relative to the ship. That is, if the ship moves, the waypoint moves with it. For example, using the same instructions as above, F10 moves the ship to the waypoint 10 times. So 100 units east, like it's 10 units east, so times 10, 100 units east, 10 units north, leaving the ship at east 100, north 10. The waypoint stays 10 units east and 1 unit north, 1 unit north of the ship. N3 moves the waypoint 3 units north. I'm sorry for calling Santa Claus dumb earlier. I mean, what? These rules are, the actual rules are just weird. Moves the waypoint 3 units north to 10 units east and 4 units north of the ship. The ship remains at east 100, north 10. And then it moves to the ship to the waypoint 7 times, so 70 units east, 28 units north. The waypoint stays in the same relative location. And these I'm curious about. R90 rotates the waypoint around the ship clockwise 90 degrees, moving it to 4 units east and 10 units south. And it was, where was it? It was 10 units east and 4 units north. So it was sort of northeast for us. So R90 moves it to 4 units east still and 10 units south. Oh yeah, that's right for you guys. Right. The ship remains at east 170, north 38, yeah. And then moves towards the location. And now we're traveling a significantly, longer distance? Oh yeah, but we're going much further. Right, okay. So basically, throw out all the rules for part 1 and implement a completely new set of rules for part 2. That's fun. Let's see, what can we keep? Not much actually. The direction stuff. I'm not sure if it's worth keeping any of this, to be honest. Let's go to nope. Day 12, part 1. I am just gonna start by removing all of this. And then we are going to maybe copy in some stuff later on if we see that they're handy. So yeah, we need to keep track of the waypoint. Let's just call it VX for waypoint X. And it starts at 10 units east, so that's 10 and minus 1 for 1 north. Wise minus 1, and our X position and our Y position is still 0. Okay. So now we can copy this. Hello? There. Wim hung for me a second there. Oops. Yeah. So we're gonna start with the same kind of style that we did previously. We might change this. So this, as you can see, like it moves the ships to the waypoint 10 times. We don't really have to do like a for loop of moving towards it, because it's just timing it by this number. And remember, this is the relative position to our ship. We're not storing its absolute position, because then we would have to update it for every tick. So we are just going to say let times be the integer that we parse from the line. You know what? All of these numbers have a, like all of these things have a number part, so let's just parse that in the beginning. Number times Vx, and the same for this Y. Let's do some nicer spacing there. So that's our rule for forward. Yeah, so this north, south, east stuff. Is basically the same. This is another way of doing it, by the way. A case can have multiple labels. North, south, east, west. But again, this isn't really the best way sort of doing this. You know what? Let's copy this. Sort of keep it similar to what we had. We're gonna do this. And let's just rename this to just heading, because we don't have a global heading value any longer. Let's also grab our type definition here for the direction. And of course, this is not named, this is not named speed anymore. It's now just num for the number. Except then we can do this. We of course don't need this case anymore. So basically what we're doing here, we're saying parse the first character as an enum. This will only parse if it is east, west, south, north. I don't particularly like this pattern because it's kind of, it doesn't really show what the logic is here. Like if I were to put this in actual code, I would probably do something like when direction and then character, for example, and then body and otherwise about just untyped and untyped. I'll probably do something like this just to sort of again, we need to inject this as I showed yesterday. Do something like this just to sort of make the logic of our program a bit clearer. That makes it harder for us to mess up in the future. I mean, for this it doesn't matter because this doesn't have a future. There. Like now, this just complaining about missed stuff. So there, now when we read this, we can sort of see, here this expects this to be a direction, and then we can do this with the direction. I guess we should change this to when heading. Right, there's a bug in the MLSP. It doesn't rename the name of the template when you, like, it renamed this one, but not the template. I had to do that myself. Oops, I should fix that. Yeah, and this do, this is kind of weird. I would like if we were able to sort of specify this word, or just like pick it from like else, and like I would, in this case I would like to have else here, and in fact in most cases when I do my second branch, I want it to be an else branch. So I would like if there was some way of this to be else instead of do, because now we had when heading this and then do. What, we're not doing anything. Like this do is, yeah, else would be nice. Anyways, so we have this is of course, so now we're moving the the waypoint around, not ourselves. Kind of important to remember. And this is the important part, or the interesting part. Rotates the waypoint around the ship. But you can see what happens is when he rotates, so he rotates the waypoint around the ship clockwise 90 degrees. It was 10 units east and 4 units north. When he goes 90 degrees clockwise, it just moves to 4 units east and 10 units south. So it just like flips them around by some rules. And this would be sort of the case always. So these numbers stay the same, but the cardinality of them would change. So instead of doing actual math and risking sort of bringing some floating points in precision, like with sign and stuff like that into this, I think what we want to do is we want to implement that that logic for this. But this might be interesting too. Whoops. This might be interesting to see. Right. So when moving right, east swaps to south. So what would happen if we're going this way? Wait, I should draw this. So we're here. Currently we have 10 units east and 4 units north. So we're this would be a right for you. So we're 10 units east here and 4 units north, which would put us about here. So the waypoint is here. Now it says turn right by 90 degrees. That would bring the waypoint to 4. Let me just change color. That would bring the waypoint to 4 in this direction and 10 in this direction. So as you can see, we've moved. I do not use this program a lot. Let's see. We've moved sort of this right angle. We've moved that to now be like this, right? Not drawing over my little waypoint flag there. So all we've done is sort of like translate our stuff down there. Or actually what we have done is we've gone 10 down this way, 4 over this way. So as you can see, this is the same as this. It's meant to be. So if we did 90 degrees more, we would end up over there. And I'm not going to continue this drawing for hopefully obvious reasons. That was put us over there for that would be 180. So a 180 would just change the sign of the x direction. No. Yeah, 180 would change the it changes the sign of this, and it changes the sign of this. That's a 180. So instead of going out and up, we're going left and down. So 180 is just a sign flip. That would be true for left and right. When we go right by 90, then we are swapping our east for south and our northeast for our east-west for a north-south. I mean, if it was over here and we would go up here. So 90 degrees from this position would be up here. So it would be the same thing. We're changing this for this. And this is negative and this is negative, so that's fine. I mean, we are we have defined ourselves as being sort of like in origo, like speed wise. So this is like 0, 0 speed wise in the center here, and this is at 10 minus 4 speed wise. This is at This is at 410 speed-wise. And this is at minus 10, 4 speed-wise. So as I said, just sign flip. And the position up here would be at minus 4, minus 10. Right. So when moving right 90 degrees, this XY, like the XY position flips, but also the sign of this flips. When going here, they also flip, but both signs flip. Is there a rule to which sign flips? Wait, okay. Let's just start by we start by a special case. Let's just take them both at the same time, I think. I mean, left and right is sort of, you can just add or subtract to one or the other to get the other one. In fact, let us just, we have our test data here, which only has a right and not a left. So let's start by just programming the right. That means our, if num is equal to 180, so if it just says reverse, then as we said here, we're just flipping the sign of both. So Vx times equals -1, Vy times equals -1. And now if we're going down, like if we have 90 degrees, then we're changing them over, but also changing the sign of the first one. If num is 90, so 90 degrees here, let's just keep a temporary x and say that Vx is Vy and Vy is Tx, and say that Vx should flip sign. And if we're going left, we're not flipping the sign of this, we're only flipping the sign of the second one. So if the number is 270, then we're doing this, but it's Vy that flips sign. We don't have any 360s. If we did, we could just ignore them. So that is for right. So this should theoretically already work for the test case. So let's try that. There. Split into lines. Oh, oops. There. Nope. Oh, maybe we should echo out something here. Echo out x, echo out y, echo out absolute x plus absolute y. Just the same as we did before. So that gives a 286, which is what we expected. Nice. 214, 72, 214 and 72. This is 72 north. Well, seems like we have flipped design here somewhere. Was that not supposed to start at 10 units east and 1 unit north? So is this due to the rotation thing? Let us, for each iteration, just write out the separator and write out the waypoint position. Actually, let's draw that out as sort of proper coordinates. Come on. Let's actually also just echo out the line. There we go. So forward 10, it doesn't change. North 3, yeah. North 3. So now it should be 4 units north. Then F7, that doesn't change it. R90, I'm guessing this is the one that messed up. It should be 4 units east, so X is 4 and 10 is Y. That's actually correct. Wait, what? So all of those seems correct. Echo out our position as well. Let's see what we got here. So we start, or we go 100 to the east and 10 to the north. We went 10 to the south. Why did we do that? Oh, whoop. There we go. Now it's correct. 214.72, which is 214 east and south 72. That is what we expect. Good. And let's do this. Now we can go back to our actual input, but we haven't implemented left yet. So left 90 is the same as R270. 180 is always the same, and this one is also sort of opposite. So we can say for R or L, and we can change here to not use num but use direction, and we can say that direction is equal to if line 0 is R, then it's just equal to num, because that's the logic we have implemented. Otherwise, it's equal to, so if it is L, it's equal to num what would that be? Minus or plus minus 270. Num plus 270. No, 180, of course. But that would not. That would make 180 commands into a 270 command. So let's put this after this. This should just stay as number. And then otherwise do all of this stuff. Let the direction be this. And this should of course be the same. Well, this could just be a normal mod of 360. So if we say go left by 90, we add 180. So that's the same as saying right by 270. And if we say we want to go left 270, we say actually it's left by what would that be? 450? Is that right? My math, like doing calculations in my head, was never my strong suit. Yeah, 450. And then of course modulo that by 360 is 90. So that would be the same as going right 90. And we have already treated the 180 case, which is the same for both left and right. So this only applies if it's not that. Great. So this should implement all the rules correctly. And this should be our answer to part 2. Hurrah! Okay. So that was ooh, it's getting lush and green, and we have headed up this way. So yeah, that was day 12 of Advent of Code. I hope you liked it as usual, or I don't know if you usually like these, but I hope you like this one. I will try to also stream tomorrow. Hopefully I will find time for that. And I will try to keep these streams going because I think they're kind of fun to do as well. And I plan on making a post on my website. Maybe I should just do one already for those who are subscribed to the RSS newsletter. For those who don't know, this is my website where I mostly write about Nim. Yeah, as you can see, the last 5 points are all about Nim. So yeah, I will probably post something here. Last one was from June. Jesus Christ. About that I'm doing these, and sort of embed the videos there after they're done. Yeah, I hope you have continue to have a good Advent, and hopefully you'll have a good Christmas as well when that time arrives. That's all from me today. Goodbye.